Ayan. Okay. So, our first example is a 3-kilogram block starts from rest at the top of a 30-degree incline and slides a distance of 2 meters down the incline in 1.5 seconds. Okay. Find A, the magnitude of the acceleration of the block. B, the coefficient of kinetic friction between the plane and the block. And C, the friction force acting on the block. And D, the speed of the block after it has slid 2 meters. Okay. So first is we need to draw, let's try to draw the illustration of the block. Narinig na ba? Class, narinig niyo naman ako? Na?
Opo, narinig po, sir.
Okay. Sige. Thank you. So, draw muna natin yung figure nung problem natin. So, meron daw tayong inclined plane at yung angle of inclination is 30 degrees. Ayan. And then, so meron tayong block which starts from rest at the top. So, sabihin na natin nandito siya. So, ito yung block natin. And it will slide 2 meters down the incline. So, mag-slide daw siya dito ng 2 meters. Sabihin na natin yung buo ay 2 meters. At yung time para ma-travel niya yung 2 meters is 1.5 seconds. Okay? Ang unang question ay, ano daw yung acceleration ng ating block? B, the coefficient of friction. And C, the frictional force. And D, the final speed or velocity. So, parang review rin ito ng kinematics na may halong Newton's law. Ayan. Okay. So, we are to find the acceleration muna. Okay? So, kaya ba nating kunin yung acceleration without even applying the second law? Okay? So, sabi kasi dyan, at initially, ang object natin is at rest. So, letter A, ang initial velocity natin ay 0. So, we have the displacement na 2 meters and then yung time taken is 1.5 seconds to travel that displacement. Okay? So, hinahanap natin ay yung acceleration. So, therefore, we can say that delta x is equal to VIT plus 1/2 AT squared. So, VI is 0, so this term is 0. So, you have 2 is equal to 1/2 times A times 1.5 squared. So, acceleration is cross-multiply 4 over 1.5 squared. So, the acceleration is 1.78. 1.78 meters per second squared. Ayan. So, 1.78 meters per second squared. Okay. May question? May question ba sa example natin? Tataw, bakit nagpupog dito? Okay. So, yung next natin ay yung coefficient of friction. So, dito, wala tayong magagawa kung hindi mag-Newton's laws of motion na tayo. And before we can do that, so, una is we need to draw the free body diagram. And before we can do that also, okay, and before we can do that also, we need to identify first all the forces acting on the object. Okay, so given this figure, so what are the forces acting on the object? Okay, una, yung weight. So remember, yung weight natin is always downward regardless of the position of the object. it will be always directed downward. So the weight is downward. Okay? Next is normal. Normal is always perpendicular to the surface. So if this is the surface, so ito yung normal force natin. Normal. Okay, do we have a tension? Tension, no ropes or strings. No rope strings are present, so therefore no tension. How about friction? Okay, so meron tayong coefficient of friction and then ang tendency pag inaantad. So ang motion ng object natin ay ganito yung magiging acceleration. So motion is pababa dun sa incline. So therefore, ang direction ng ating frictional force should be opposite that motion. So therefore, frictional force natin is in this direction. Okay? So yung frictional force natin is in that direction. Ayan. Meron pa? Okay, wala. Okay, so let's draw the FPD of our figure. Ayan. So, okay class, kung gagawin natin yung FBD nito, so dapat ay, okay, mag-rotate tayo ng axis. Since naka-incline siya, so that means the axis should be rotated such that the x-axis is parallel to the surface. Kung ito yung surface natin, okay, so the x-axis should be parallel to it. Yan, ito yung x-axis natin at ito yung magiging y-axis natin. Ito yung x-axis, tapos ito yung ating y-axis. Okay? So, tingnan natin yung mga forces existing. So, if we will view it in this way, yung normal natin is going upward, so it's positive. Okay? And then yung frictional force is to the left. Okay? And then yung weight natin is on the fourth quadrant. And how will we refer 30 degrees? So 30 degrees ay laging kadikit niya yung y-axis. So nandito yung ating 30 degrees. Okay, 30 degrees. So I have derived that before, so you can check the discussion natin last time regarding this. Ayan. Kung paano naging 30 degrees. Ayan. So meron pa ba? Okay, so don't forget the direction of the acceleration. So if you will view it in this way, so it's going to the right. So acceleration is in this direction. Okay? So after drawing our FPD, okay, huwag niyong kakalimutan yung components ng ating weight. So meron siyang X component at saka Y component. So let's call this WX and ito naman ay WY. So WX and W. May question? Ayan. Okay. So next one class is saan tayo magsisimula sa pag-apply ng second law after nating ma-draw yung ating FPD. So after drawing the FPD, saan natin sisimulan yung second law natin? Is it along X or along Y? So lagi naman ganito yung nagiging decision. Okay, kung saan natin i-apply yung ating second law. Pero para makatulong sa inyo, para mag-decide, always yung isipin is, or tatanong ay, meron bang frictional force? Okay? Kung merong frictional force, ibig sabihin, or coefficient of friction, ibig sabihin, kailangan natin yung normal force. Remember, ang formula ng ating frictional force is equal to mu n, where mu is the coefficient of friction, and then n is the normal force. Diba? Ang formula ng frictional force natin ay equal siya sa mu n. So, ito ay coefficient of friction and this is the normal force. Kung wala tayong existing na frictional force or let's say frictionless yung system natin, hindi na natin kailangan yung normal kasi hindi naman natin siya gagamitin. Pero kung ang system natin ay meron siyang frictional force, so that means kailangan natin yung normal So ang dapat nyong gawin, unahin yung kunin yung normal force. Okay? Kung nasaan man ang component, nasan mang component yung normal force, yun yung unang-unang yung hahanapin. Doon kayo unang-unang mag-a-apply ng second law. Kung nasaan yung normal force. Kasi kailangan natin yung normal force. Okay? Okay, so looking at the FBD, so ano ang axis? Nasa ang axis, existing yung normal. So kung titingnan natin nasa vertical axis, so that means it's along Y. So sisimulan natin ang second law ni apply sa Y. So summation of forces along Y is equal to MAY. Ang assumption natin lahat ng pataas ay positive. Okay? Kaya question lang, class, is let's go back to the FPD. That's why it's very important to note kung nasaan ang direction ng acceleration. Saan ba nag-accelerate yung object? Di ba nag-accelerate lang siya along X? So that means acceleration along Y is not existing, so it is 0. Okay? Because the acceleration of the system is only along, or the object is only along X. It's not accelerating along Y. Okay, so therefore, the summation of forces along Y is equal to 0. Kasi wala siyang acceleration along Y. Okay, now, let's get the summation of the forces. You identified the forces. So see, lahat ng forces, dalawa lang. Itong dalawa, normal and WY. So, ang assumption natin pagpataas ay positive. So therefore, normal minus WY is equal to 0. Normal force, ayun, pataas, WY pababa, kaya minus. Is equal to yung mass but acceleration is 0. So therefore, just equate it to 0. Ayun. Okay? And then let's just continue. So therefore, normal is equal to WY, which is equal to W. So let's draw a figure. How will you get WY? Since yung angle natin ay nakadikit sa WY, so cosine siya. Cosine 30 degrees. Na-guess nyo ba yun? Bakit di siya sine 30? Bakit cosine 30 siya? Kasi yung WY ay adjacent siya ng 30 degrees or kadikit siya ng 30 degrees. Diba? So, katawa. Okay? So, since adjacent siya ng WY in 30 degrees, kaya cosine yung WY. Okay? So, therefore, normal is equal to, what's the weight? Weight is 3 kilograms times 9.8, which is gravity. Remember, weight is equal to mg. So, times cosine 30. So, the normal force is equal to newtons. 25.46 newtons. Okay? 25.46 newtons. Okay, next is, let's proceed to X. So, summation of forces along X is equal to MAX. So, pakanan ay positive. Okay, again, let's look at the figure. Ayan. So, what are the forces along X? So, wag niyo nang intindihin yung W dito kasi kinuha na natin yung components niya. So, pakanan ay positive. So, we have WX, wala na, and then minus the frictional force is equal to mass times the acceleration. Okay? Okay, so what's a WX? So, based on the figure, since ang angle ay nandito siya, so magiging siyang sine. So, that's W sine 30 minus mu n, that's equal to MA. Ayan. So, substitute na lang natin. So, we'll have 3 times 9.8 times sine 30 minus mu times normal. So, normal force is 25.46 is equal to 3 times the acceleration. So, acceleration natin, ina-compute natin sa kanina, which is 1.78. And then we can compute for our coefficient of friction. So this is negative mu times 25.46 is equal to, okay, class transpose yun na rin yun. Okay. It's 9.36 Newton. Negative. And divide this na natin ng 25.4, negative 25.46. So the coefficient of friction is 0.37. Okay? 0.37. Okay, ang letter B natin ay nahanap natin yung frictional force, and that is mu n. So therefore, so that's equal to 0.37 times yung normal force na 45 at 25.46. Okay, so what's our frictional force? It's 9.36 newtons. Okay, 9.36 newtons. C pala, C na pala. Okay. Ito ang B, yung C. Okay, and then finally, the last one is, what is the final velocity? So if you will go back to the given dito, okay, so yan. So final velocity natin is V initial plus 80, but initially 0. So therefore, V final is equal to, acceleration is 1.78 times 1.5. So V final is equal to 2.67. Okay, so for the last one is we are to find the velocity or the speed of the object as it traveled 2 meters or 1.5 seconds. So we just use a kinematic formula. V final is V initial plus 80, wherein the initial velocity is 0. So therefore, V final is equal to the time and the acceleration. So we'll get 2.67 meters per second. Okay? So, do you have any question on our first example? Okay, so let's proceed to our second example. Okay. So, we are given this figure. Ayan. So, malinaw ba ang figure natin? So, two objects are connected by a light string that passes over a frictionless pulley as shown in the figure. Assume the incline is frictionless and take 1 meter, M1 as 2 kilograms and M2 as 6 kilograms. And the theta or the angle of inclination of the plane where M2 is lying is 55 degrees. Okay, so letter A, draw the free body diagrams of both objects. So, but we'll do that naman kahit hindi naman yun itatanong. And B, find the magnitude of the acceleration of both objects. And C, the tension on the string. And D, the speed of each object 2 seconds after it is released from rest. Okay, so unahin na natin yung letter B, which is the magnitude of the acceleration of the objects. And then yung tension sa string. Okay. So, same lang dami ng strategy natin. Ang strategy natin una ay mag-drawing pa rin ng FBD ng bawat object. So we need to identify all the forces acting on the objects. Okay. But first, since meron tayong ganitong klaseng example and we don't know if saan pupunta yung object natin, kailangan natin mag-assume. Una, hindi kasi tayo given ng applied force. So wala tayong applied force, kaya hindi natin alam kung saan pupunta yung object. Okay? So pwedeng bababa yung M1 tapos tataas yung M2 or baliktad. Bababa yung M2, tataas naman yung M1. So kailangan maging consistent lang tayo dun sa assumption. Okay? So hindi po pwedeng bababa yung M1, bababa din naman yung M2. So yun hindi po pwede yun. Okay? So kailangan din natin isipin or imaginean kung ano mangyayari din sa motion ng dalawang object. O hindi rin naman pwede na tataas silang pareho. Hindi naman din yun pwede. So kailangan maging consistent tayo sa assumption natin. O pwede rin naman hindi sila gagalaw. Pero syempre, kailangan natin mag-assume na mag-accelerate sila. Or else, wala sila sa second law. Nasa first law sila. Okay. Okay. Anong gusto niyo assumption na gawin natin? Alin ang bababa? Yung M1 or yung M2? Okay, si Jericho may suggestion. M2 yung bababa. So, M2. Okay? So, kung M2 yung bababa, so that means itong M2 ay mag-accelerate siya in this direction. Okay? In this direction. So, that means magiging consistent tayo kung yon mag-accelerate in this direction. So, therefore, dapat yung M1 naman ay tataas at meron siyang ganitong acceleration at ang kanyang direction acceleration. So, yan yung magiging assumption natin. Okay. So, next. After that, let's identify all the forces acting on each mass. Okay? Acting on each mass. So, ano yung mga forces dito sa M1? So, sa M1 ay yung weight. So, let's call that weight 1. Okay? Which is always downward. And then we have a tension, which is always away from the object. Meron pa? Okay, meron bang normal force? The object is not lying on the surface, so walang normal force. So meron bang frictional force? Wala ring normal, so walang friction. Wala na. Okay? Okay, you tell me kung meron kayo naisip. Okay, next. Sa mass 2, so meron din tayong ulit weight, which is always downward. Remember? And then meron din tayong tension, which is in this direction, away from the object. And we also have the normal force. So normal force is in this direction. Okay, how about frictional force? Do we have frictional force? Applied to M2. Hmm. Um, you read the problem again. Okay, kasi ang sabi sa atin, I assume that the incline is frictionless. Ayan, frictionless. So therefore, wala tayong frictional force. Okay? Ayan. So ganyan lang siya. So wala tayong frictional force. Okay, so let's I think can we proceed now? Ayan. So let's proceed to the next part. Okay, now let's draw the FBD. Okay, unahin na natin ang mass 1. Ayan. So sa mass 1, meron tayo yung tension and then yung ating weight 1. And ang acceleration natin ay pataas. Ayan. So wala naman tayong along x, so along y lang siya. So summation of forces along y is equal to MAY. Ang pataas ay positive. Ganyan. So what are the forces along y? So dalawa lang sila. So yung tension pataas was positive minus weight 1 is equal to mass 1 times positive acceleration. Kasi pataas yung acceleration natin kaya positive siya. Okay? So tension minus ang weight natin, remember weight is mg. So ang weight natin ay 2 kilograms. So that's 2 times 9.8 is equal to 2A. So tension minus 19.6 is equal to 2A. So let this be our first equation. Okay, so yun yung ating first equation. May question? Okay, next. Let's have yung naka-slant yung ating mass 2. So ang gagawin natin is assume natin na ito yung x-axis ay magiging parallel dun sa surface at syempre perpendicular yung y-axis. Kung ito yung x at ito yung y-axis. So yeah. Okay? And then okay, let's draw the forces. So the forces are, okay, we can see the normal. So normal force. Okay, and then yung tension natin is to the left. Okay, acceleration is going to the right. And then yung normal, yung weight natin dito ay nasa fourth quadrant. Okay, yung theta natin ay nandito. So that is our 55 degrees. Okay, now let me remove that again. Ayan. Okay, so wag niyo makakalimutan na yung weight natin ay kailangan natin nakunan yung kanyang component. So meron tayong WX2 to W2X kasi weight to to. And then we have also the W2Y. Okay, right class. Next. Yeah, saan natin uunahin kunin yung application ng ating second law? So nasabi ko kanina, if meron siyang friction, unahin yung normal. Pero kung wala naman siyang friction, huwag yun ang kukunin yung normal. So we can skip that part. Because even if we get the normal force, we don't have any use for it. Kasi wala naman tayong frictional force. And then the acceleration is not in the direction of the normal force, so we don't need yung normal force. So wag na natin kukunin yung normal force unless it is being asked. But since hindi naman siya tinatanong, wag yun ang kukunin. Okay? Since hindi natin siya kailangan. So, hindi natin siya kailangan, didiretso na tayo sa x. So, summation of forces along x is equal to MAX. Ang pakanan ay positive. Okay? So, lahat ng pakanan na. So, nandito lang tayo mag-focus. Dito. Ayan. So, meron lang tayong W2x minus t is equal to M2 times positive A. Okay? Kasi urgent para may tanong. Okay. Okay? Sige. So, let's continue. Okay, ngayon, ano ang value ng W2x with respect ngayon doon sa W natin in the angle? Okay, so I can see if this is WX, yung angle natin is hindi naman malapit sa kanya. So, therefore, it is not a cosine. So, magiging siyang sine. So, this is W2 sine 55 minus t is equal to 6a. Ayan. Okay, so therefore, this is 6 times 9.8 sine 55 minus t is equal to 6a. So, simplify lang natin to. So, 6 times 9.8 times sine 55. It's 48.17. Minus t is equal to 6a. So this is our second equation. So second equation. So ang gagawin lang natin ay mag-equate lang tayo ng equation. So meron na tayong dalawang equation kasi meron tayong dalawang unknown. So if you will go back to our first equation, ayan. So simultaneously solve lang natin siya kasama dito. So ililipat ko na lang sir para magkatapat yung 19.6. Tapos nandito yung plus t is equal to 2a. 2a. So this is our first equation. Okay? Since opposite na yung sign nito, i-add na lang natin yung dalawang equation. So cancel. So this is a 28.57. Is equal to 8a. So divide lang natin ito ng 8. So therefore, acceleration is equal to 3.57 meters per second squared. Ayan. Tama ba ang pag-compute? Okay, 3.57. Okay, so it's 3.57. Okay, so we have found yung letter B, yung acceleration is 3.57. Okay, now let's go dun sa tension. Sa tension, pipiliin ko na lang yung equation 1. Okay? At equation 1, so tension minus 19.6 is equal to 2 times 3.57. So what is the tension? Okay, so multiply nyo ng, tapos i-transpose nyo lang 19.6. It's 26.74. The acceleration and the tension. Okay? Any question? Okay, class. So, in-assume natin ang bababa yung M2 since ang naging sagot natin ay positive. So, therefore, yung assumption ay tama. Sir, ba't po yung N upward? Di po ba downward sa Y? Ah, this is our figure. So, dito natin kinuha. Direction is towards the object and perpendicular to the axis. So, ang direction niya pataas, yung normal. Okay, so that's why it's always it's upward, up papuntang Y. That's why upward, normal. Okay? So ayan. Okay, next. Ang next question ay the speed of each object 2 seconds after it is released from rest. Okay. So that means meron na tayong ano, since magkadikit lang naman yan, so pareho lang yung speed nila. So sa letter D, ano daw yung final velocity or yung magnitude ng final velocity which is the speed. So initial velocity natin ay 0 since it started at rest. And then yung, ano pa ba? Yung time na given is 2 seconds. And yung acceleration ay 3.57. So yung na-compute natin, so that is the acceleration. So ang tinatanong, ano yung final velocity? So final speed then is equal to V initial plus AT. Ayan. So V final is equal to, this was 0. So that is 3.57 times 2. So the final velocity is 7.14. So 7.14 meters per second. Okay? Okay, any question on our example? Okay, kung wala, so let's proceed to our next example. Okay, Robin. Wala? Okay, akala ko nagtatype ka ng question. What concern? Okay, so let's proceed to this example. Ayan. Okay, two blocks of mass 3.5 kilograms and 8.5 kilograms are connected by a massless string that passes through an frictionless pulley. So yung pulley natin ay frictionless, kino-considered na frictionless, to. Okay, and then assuming na yung string natin is massless. So negligible mass. Okay, so the inclines are also frictionless. So puro frictionless tayo atangin. Okay, so find find the magnitude and of the acceleration of each block, and B, what is the tension on the string? Parang similar lang sila ng example natin kanina. No? What if palitan natin? Bigyan natin silang friction. Okay. So, ganun pa din naman ang approach natin. So, mag-FPD pa rin tayo. Kaya lang, this time we need parang hindi na natin kailangan mag-assume pala dahil yung angle ay pareho, no? Or alam na natin agad kung saan pupunta yung objects natin. Kasi yung angle ay pareho, so that means we can assume na yung objects natin, ano yung bababa? Since yung angle ay pareho, so yung bababa ay yung, 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 okay, yung 8 kilograms. So yan. So yun yung magiging unang assumption natin na ang bababa ay yung 8 kilograms. So nandito yung 8. So bababa, so dito magiging direction ng acceleration. Kung bababa yung 8, yung 3.5 naman ay tataas. So ito na ang direction ng acceleration. Okay, same din naman ang analysis natin. Okay, same pa rin. So we will identify the forces acting on each object. So we have yung normal, weight 1. So tawagin natin ito yung 1. And then we have the normal force. And then we have the tension. Yan. Since wala tayong frictional force, so wala tayong ialalagay kasi frictionless daw yung incline. So ganun din dito. So yung weight niya, so weight 2. So we have the normal force. And then we have the tension. So, okay, so wala rin tayong friction dun sa 8 kilograms. So, wala din. So let's draw the FBD. So let's go with the FBD of 1. So yung mass 1, so yung FBD niya ay, okay, so gagawa tayo ng bagong X and Y axis. Niro-rotate natin sila. Yan. So ito yung X natin at ito yung Y component. Yan. So if you will check, ang tension natin is to the right. So if you will rotate it like this, so to the right, normal is pataas. And then weight is on the third quadrant. So normal, pataas. Tension is in this direction. And then yung weight natin ay nasa third quadrant. Okay, and this angle is 35 degrees. Okay? Again, we need to consider the components of our weight dahil meron siyang angle. Okay, so ito ang magiging W1x. At ito naman yung W1y. Okay? Ang acceleration natin is parallel doon sa tension. So nandito yung direction of acceleration. So pakanan siya, so that means it's positive. Okay, next. Do we have friction? Okay, since wala tayong given na friction, wag na natin kukunin yung normal. Okay? Wag nang kukunin yung normal since wala namang friction. So didiretso na tayo sa summation of forces along X is equal to MAX. Tama, MAX. Pakanan ay positive. So we'll have tension minus W1x is equal to mass 1 times the acceleration. So 1 is W1. So angle is X yung kinukuha. So that means kung nandito yung angle, so it should be sine 35. So that's equal to mass 1 times A. So tension then minus weight 1 is 3.5 kilograms times 9.8 times sine 35 is equal to 3.5 A. So tension is equal minus in 19.67 is equal to 3.58. So tama ba yung computation ko? 3.5 times 9.8 times sine 35. Okay, 19.67. Okay, so this will be our first equation. Okay, so yan yung ating first equation. Okay, mag-next paper na ako. Parang feeling ko hindi naman kakasya yung solution. So, let's proceed to mass 2. Okay, same lang ang gagawin. Kailangan natin i-parallel, or I mean, i-rotate yung axis natin such that the x-axis is parallel doon sa surface natin. Ayan. So this is X and this is Y. Ayan. Okay? So therefore, if we will draw the FBD, so normal is still upward. And then tension is to the left. And then a weight is on the fourth quadrant. So nandito yung weight at nandito yung 35 degrees. Okay, and acceleration is in this direction. So, yan. Okay? Next, since again, since meron tayong component for y, w, so this is w2. So w2y and w2x. Ayan. And again, since frictionless ito, we don't need yung normal 2. So hindi na natin kailangan computein yung normal 2. Okay, kasi wala naman tayong frictional force. So gagawin natin, ididiretso na natin siya sa summation of force along y, x is equal to MAX. So what are the forces along x? So nandito yung mga forces along x. So W2x minus T is equal to mass 2 times A. So W2 is, x is, since W2 yan, nandito yung angle, 2 sine 35 minus T is equal to M2A. So W2 is 8 times 9.8 minus T is equal to 8A. So nawawala yung sine 35. So that's 8 times 9.8 times sine 35. Okay, so that is 44.97. Minus T is equal to 8A. So this is our second equation. So we equate that to this equation. So therefore, we will have negative 19.67 plus T is equal to 3.5. 3.5 naman. Okay, A. And then we just add. So, cancel yung T. So, ang matitira ay yon minus 19.67. So, 25.3 is equal to 11.5. So, divide this A. So, divide this by 11.5. So, the acceleration is equal to 2.2. Okay, 2.2 meters per second squared. Ayan. So that's the acceleration. And yung B natin ay, ano yung tension? So yung tension at equation 1 na lang. Ilagay akong sa equation 1 kasi positive yung tension doon. That's why. Para hindi ko na siya tinatranspose. So at equation 1, ito. Okay, so tension minus 19.67 is equal to 3.5 times 2.2. Ayan. So what's the tension? So transpose yun ng 19.67. Is 27.37 newtons. Ayan. So ito yung final answer. Okay, may question? Okay, so kung wala kayong question, let's proceed to this example. Pero class, can we have a short break lang? we're given two figures here. So figure A and figure B. And we are to find the tension on each of the strings. So meron tayong tatlong tension. So kasi meron tayong tatlong strings, that's why we have three tensions na unknown. So ang question lang, I find the tension in each of the three strands of cord supporting each load. Okay, I will only solve the first one, and then I will let you do your on your own yung second one. Okay, mas madali yung second kasi sa first. Ayan. Okay. Unlike the other examples that we had, so this one is quite different because if this figure system is not under this type of figure is not under the second law because the objects are not accelerating. So therefore, the objects are under the first law since the net force acting on each one is considered zero. Okay? So wala tayong acceleration dito because no object is moving. Ayan. And at the same time, as I've mentioned before, when we are drawing FBD, we consider the number of FBD depends on the number of objects or number of mass. Pero pagdating dito sa ganitong klaseng problem, meron tayong parang special na i-consider na mass. Hindi siya mass, pero i-consider natin siya or gagawa natin siya ng FBD. Even dahil dati, di ba nasabi ko, or na-mention natin na ang mga FBD ay parang yung mass is gagawin mo siyang isang dot kung saan lahat ng forces ay mag-axila doon. So, ganun din ang gagawin natin. So, parang yung merong special na dot and then lahat ng forces acting on it, i-consider din natin. Okay. So, una, walang gumagalaw dito. So, that means acceleration is zero and that means all the summation ng forces na gagamitin natin ay pare-pareho silang equal to zero. Okay? May question ba sa sinabi ko? Okay. So, isa pa, paano ba magsimula dito sa example na to? So, una, magsimula kayo doon sa may given tayo. Or particularly, kung saan may mass. So, doon lang lagi magsisimula. Doon sa may mass. Okay? Sa may mass lang. Or doon sa may weight. So, doon tayo magsisimula. So, isusolve natin yung A. So, halimbawa dito sa A, okay? So, ang sisimulan natin siya sa 5 kilograms. Okay? So, ano yung forces na nag-act sa 5 kilograms? Okay, so meron tayong weight at saka meron tayong tension. So, yun yung tension 3. Ayan. So, meron pa ba? Diba wala na. So, that means, okay na yun sa FBD natin. So, mag-drawing tayo ng FBD. Ayan, para sa 5 sa mass. Okay? And then, yung mga forces na nandyan ay, so una is yung tension 3 and then yung ating weight. Tension 3 and weight. Okay? Since wala naman ibang forces acting on any other direction except for the vertical, so therefore, doon na lang tayo magsisimula. So the summation of forces along Y is klase diretso ko ng 0. Kasi nothing is moving naman eh. So nothing is moving, so it's a 0. So lahat ng pataas ay positive. Okay, so that means yung tension 3 minus weight is equal to 0. So tension 3 is equal to weight, which is 5 times 9, mass times gravity, 9.8. So yung tension 3 natin ay equal siya sa 49 newtons. So yung tension 3 natin is equal siya sa 49 newtons. Okay. Ngayon, that means, tapos na tayo dito. Ngayon, paano tayo pupunta sa T1 and T2? Ito yung sinasabi kong exemption. Na hindi lang naman mass yung ginagawa natin ng FBD. Pati yung mga nut or buhol. Or kung saan nagdudugtong-dugtong yung mga cord. Okay? So, tatas tayo dito. So, meron tayong knot dito. So, tawagin natin yung knot 1. So, gagawin din natin ng FBD yung knot 1. Yan. Okay? So, gagawin din natin ng FBD yung knot 1. So, ano yung mga forces acting on knot 1? Okay? So, meron tayong tatlo. So, we have yung tension 1 dito. So, tension is always away from the object. And then, nandito rin yung tension 2. And nandito rin naman yung tension 3. Okay? So, tatlo sila. So, drawing ko na sila. Ayan. So, nandito yung tension 3. Okay, yung tension 3. Okay, nandito yung tension 2. Okay, at nandito yung tension 3. O tension 1. Okay, ngayon meron tayong mga angle. Okay. So meron tayong mga angle doon sa taas. Ngayon, how are we going to refer them dito sa ating FBD? Kung titignan natin, if you will draw a horizontal line dito passing through our knot, ayan, horizontal line, di ba kung dire-diretso yan, ayan, so that means ito, tsaka to perpendicular. Kung 50 yon, ito, tsaka to parallel, so therefore ito ay 50 din. Okay, so ito din ay 40. So that means this is 40 degrees and this is 50 degrees. Ayan. Okay? Kasi parallel ito, so ito is straight line, so that means yung opposite angles will be equal. Tama ba? Ayan. Okay? And then, ang gagawin natin ay, ayan, kukailangan natin yung component ng bawat yung dalawa. So, yung component nila ay ito. So, yung T1Y, ay nasumulat. Wala na akong red. Yung T1Y. Okay, and meron din tayo dito, T1X. Okay? And the same time, yung sa taas, para dito ay T2Y. At nandito naman yung T2X. Okay. Ayan. Okay? Ngayong laso, saan natin siya uunahin? Okay, unahin natin siya sa pinaka-konti. Okay? So, pag ginawa na natin yan, huwag nyo nang iisipin ito at saka to. So, i-consider na lang natin yung components nila, yung T1Y, yung T2Y, T1X, at saka yung T2X. Ayan. Okay, so natin sa unahin yan. So, unahin na natin siya sa pinaka-konti. Along X, dalawa lang, T1X and T2Y, T2X. Sa Y kasi tatlo, T1Y, T2Y, at saka T3. Okay? So, unahin na natin siya sa X. So, summation of forces along X is equal to 0. So, we'll have pakanan ay positive. So, T2X minus T1X is equal to 0. So, T2X is equal to T1X. But what is T2X? So, T2X is, so adjacent siya ng 50. So, therefore, that's T2 cosine 50. Okay, so that's equal to, yung Y naman is adjacent siya ng 40. So, T1 cosine 40. Yan. Okay? Okay, next. So, let's proceed to Y. Okay, so sa y naman ay okay, summation of forces. So check ko natin. Summation of forces along y is equal to 0. So pataas ay positive. So yung pataas natin is yung T1y plus T2y okay, minus T3 is equal to 0. Ayan. Okay, so therefore, T1y plus T2y is equal to T3. But T3 is 49 newtons. So T1y plus T2y is equal to 49. Kaya lang, ano ang T1y? So if you consider natin ito, ang T1y nandito at opposite siya ng 40. So that will be T1 sine 40. Okay? Plus T2. So yung T2 naman, opposite siya ng 50 sine 50. So it's equal to 49. So this is our second equation. Okay. So yung first equation natin ay nandito. Okay? So kayo na bahala kung anong gusto yung gawin. Kung substitution ba tayo or mag-elimination. Para sa ganito, para sa akin ay mas madali ang substitution kasi cosine mga yan at saka sine. So from equation 1, okay, so T2 cosine 50 is equal to T1 cosine 40. So divide natin to ng cosine 50. Ayan. So T2 then ay equal siya sa T1 cosine 40 over cosine 50. Next. And then i-substitute natin ito dito sa equation na yan. Okay? So that means that will be equal to T1 sine 40 plus yung T2 natin is a quantity T1 cosine 40 over cosine 50 times sine 50 is equal to 49. So ang gagawin lang natin is i-factor out na lang natin yung T1. So T1 times the quantity sine 40 plus cosine 40 sine 50 over cosine 50. Okay, so that's equal to 49. Okay? And then i-divide nyo na lang to ng 49. So therefore, T1 is equal to 49 divided by sine 40 plus cosine 40 sine 50 over cosine 50. So what is tension 1? Therefore, tension 1 is equal to is 31.5 newtons. So tama ba yung computation ko? Pwede mo paki-compute? Huh. Okay, 31.5. Okay? And therefore, T2 is equal to 31.5 times dito, okay, cosine 40 over cosine 50. So what's T2? Okay, 37.54. Okay, so T3 natin ay yung 49. Ayan. So, yun yung ating sagot. Okay? Meron ba ang question? Wala. So, ang gagawin ninyo, pag-aralan nyo is this one. Mas madali lang naman yan compared sa kanina. Medyo mas mahirap yung kanina compared dito. So, bakit siya mas madali? Kasi mas madaling kunin yung T2 at saka yung T1. So, mas madaling kunin yung T1. So, una yung makukuha dyan yung T1. Mas madali siyang kunin compared sa T2. Okay? So, yan ang lesson natin on Newton's laws.